Hello everyone, let's continue to work on our robotic simulator with Unity and Matlab, and today it will be the part number 3. First of all, I will show you what you will have in the end of this video, and today we will learn how to sort these cubes by color. So for this procedure we will detect the color, we will create additional camera, attach it to the end effector, then it will detect particular color, and we will sort these cubes. Okay, so let's start with this example. First of all, we will detect this green cube, so it will send the image, corresponding image, to the Matlab. It will correspond to the green color, so the robot will put it to the corresponding area. Next we will move to the red cube. I'll comment this line, as the robot will have the effector to this one, then the image will be sent to the Matlab from the camera. The red color will be detected and we will put a cube here. And the last cube is the blue one. And the robot will move to this cube, detect its color with the Matlab script, and put it to the corresponding part. So that's all. That's what we will have in the end of this video. So that's what I tested before. Now let's move to our object itself. What we had in the end of the part number 2 is this one. The first thing I wanna say is the thing about the Robotics Toolbox. Before I explained you the installation with the from the GitHub page this way. So we added the path to the Matlab and we started it with the startup file, with this file. So every time you close the Matlab and open again, every time you need to start this file in order to be able to work with the Robotics Toolbox. Otherwise you will have an error, but it's not really convenient, so there is another way to install the Robotics Toolbox, to add it to the toolboxes of the Matlab. For this procedure we need to go to this page, peterkork.com, toolboxes, Robotics Toolbox. Then scroll down and download this file. We need to download. Once it will be downloaded, here you need to open it. Open install app, then go to the downloads, show all files, and select this file you downloaded. So after that it will take some time, and after that this toolbox will be installed. So you will see it here. Now if you will close the Matlab and open again, the Robotics Toolbox will work for you, so no need to start this file. So let's move to our scripts next. Firstly, let's fix the thing about our gripper. So what we have on it. So I will change it to our GitHub repository, and let's consider the gripper function here. So what's wrong with our gripper here? For example, let's start our project, and if I will start the MATLAB script itself, and if you cube here, everything will work fine for it. So the object was detected, it will grab it and move it. But if there is no object here and we start this program, it will be oh no. Let's try another way. So we hide this cube and then I will start the program. So there is no cube here. Yes, blue cube. Okay, one more time. So hide this cube, start the MATLAB. And now we don't have any cube here, so it will show us an error because we didn't specify it in our program. So now let's move to the script collide.test and fix this issue. So this error was because we didn't detect the cube, but the object by default it should detect the object. So here we have this object collided with, and we can check inside our function. We can write a statement if collided with not equal to null. This means that we detected our object, so we grab it. Otherwise we didn't detect it, so we do nothing here. So only if this object was detected we work with it. Same for releasing the object. Same here. Now let's try to test this part. Again, I will hide this cube. Start the MATLAB. So now the cube wasn't detected, and then we didn't grab this cube. So now we don't have this error here. And next, let's consider another thing about the gripper. Scripts. No. We need to find the script which is attached to our gripper. It's the script animation EE. So here we have this script, and here we have function grab. So if we change this function to 1, it corresponds, it will grab it, 0 will release it. Again, 1 will grab it, and here the thing, if I will change it to 0 very quick, then it will work fine. But if I will wait for some time and then change it to 0, oh, here it also worked fine. Okay, so now it okay, but it works not really stable, so we better do it with the coroutine as well. So we grab our cube with the coroutine. Okay, I've got it. So let's check it one more time. So when we grab the object, we work with the coroutine. So now if we wait for some time and then we wanna release our object, we wanna put 0, it will be released immediately because we worked with the coroutine. But for releasing object, we don't work with the coroutine, and here is our animation speed is equal to -1. Here we waited for some time and we stopped our animation here. But here in this function we didn't stop the animation. So now if I will try to grab my cube, I wanna start the animation, I will put 1 here and nothing will happen here. So that's a problem. So for releasing our object, we also need to use the coroutine. Let's create another coroutine here. So here we'll write this coroutine. It will be start. And we create another coroutine for stop. For stop things, and we will put this part here. And we will call this coroutine from this function. Start coroutine, here it will be stop. Again, here first of all we need to reset our grep once we entered this coroutine. Next this function, this function, this, and next we return this statement in the end of the coroutine. Again, we wait for some time and we reset our animation, stop it, make it equal to 0. Here we have function for release object, and also let's create function for grab the object, because this we need for testing. In our server script it's better to call directly the function itself, so it's not really good to compare them in the update. So here it will be grab function, grab obj, and we start this coroutine here. here let's use it for the testing purpose. So let's test our script now. So now we test both coroutines. Go to Unity and test this part. Now we can write 1, it will grab the cube, we can wait for some time and we can release this cube. Then we can now also wait for some time and then again try to grab the cube. As you remember before, we didn't work with the coroutine, so we were not able to grab it again. If I will write 1, so it will work fine now for us. So this part for testing we don't need it any longer, so we can delete it or we can hide it if again we wanna test it in the future, some other parts. So we can comment, for example, several lines this way and uncomment it later if we wanna again use it for testing. But now let's just call this function from the server script. So now let's move to the server part, and also I wanna divide these things here. It was in one function, but I wanna divide them for two functions. I wanna modify joints of the robot in one function, and I wanna modify the gripper in another function. So for this procedure we need to add a new case, and we also need to write a new function in our Matlab scripts. So here was the function data. It includes the robot joints and also it includes the grabbing part. Now let's separate them. So I will create a new function. Function will be called grab. Here it will be the mod grab. And here we will leave just the last part, which corresponds to the grab function. This one. So I don't need a B, I don't need Q. So I will leave just one parameter. So I save it. Func grab. From here I will delete the grab parameter. Grab. Grab. This one. Also save it. Then I will go to main. Here, firstly I will delete the grab part from the function, as it's not really needed from everywhere. And where we grab the object, we add the separate function for grabbing it. So here we deleted it, and next we need to use our new function grab. So where we grab our object, take object, so we grab it here. Firstly we approach to our cube, next we grab it, so we send this function to it. We wait till it will grab our object, and we don't need this one. And then we release our object. Release here. So we grab it, we release it. Next, as we edit a new case, mod grab, we also need to modify it in a Visual Studio. So here we'll have a new case. It will be the case mod grab. Let's make modifications here. Here we will write grab. Here we need to delete the last parameter, which corresponds to the grab. And here for grab we need to delete everything except the grab parameter. Here we need to also modify it to 1. Here delete grab. So this function won't be highlighted any longer. And we need to create a new void, new function for the grab. Modify grab. Here we also write it the same way. Modify grab. And leave just the integer parameter int grab. So from here we can delete it from the modify robot and also delete this part. So here we work just with the robot itself. Here we delete everything relates to the robot and leave just the grab parameter. And next, as we for our script collide the test, we remove it from the update, so we will work with these two functions. We will call them directly from our script. So in order to get access to them, first of all we need to make them, these two functions, public. Public void grab, public void release object. Next we call them here. For this procedure we need to make comparison with the grab parameter. Before we just modified this parameter and it was modified here and we compared it with the update. So now we won't use it. We will compare this parameter if grab equal to 1, we grab the object. So we call the function called grab object. Otherwise, if grep equal to 0, we release the object. Here we release object. So that's all. Next, let's try to test it. Save it and start it. Here's the Unity, here's Matlab with our new functions. So we will try to grab the cube. Start the Matlab, start the Unity, then we run the Matlab. And it shows some error in line 43. Okay, so grep should be lowercase, not capital. Inside the function we use it lowercase, so they can be different, but for the program itself they should be similar. So also lowercase here. And let's try to run it one more time. So we approach to the cube, then we grab it, we move it, we release it. So it worked. It works similar way as we did before, but here we make the separate functions for modifying joints of the robot and for gripping the robot. So we finished with the gripper part. Now let's move to the next part. So in the next part we will add the canvas. Here will be highlighted positions of every cube. Also we can hide them. Also we can see here joints of our robot. So if they are changing in the script, we will see corresponding changes here. Same with the cubes. If our cubes are changing the location, we see corresponding changes here. Also I added the point clicker here, and also I added the camera zoom, so we can move around the scene here and click a particular part. For example, now I click to the cube, green cube, so we will see similar positions here. And also if you will click any other part, so this way we can get positions of the objects we are interested with. Now let's move to these parts. It has, so we won't create these parameters manually, so I will just import these several files, and also I will import the test scene, and I will just copy some elements from here. You can also do it similar way. I will add the similar import file to the description of the video. In order to export something from one project and import to another one, we need to go to the assets. Next we click export package, and next we need to select items we wanna export. So what we wanna export from here is this test scene, this one. Also I wanna export camera scripts, canvas changes, it's this script. Also I wanna export screen point to array, is this part. So it give me a point on the plane, corresponding point I'm interested in. Probably that's all we wanna export. So next we click export, make sure that this toggle is activated, and click export. Then where we wanna save it, and can give it a name, any name, export, save. So the export, it will be exported, then we can import it to our project. We go to the project, our downloads, and just drag and drop it to here. So it will show us the items to import, and we click import. Next, I will see a new scene here, test scene. So I open it, and here I am interested firstly in the canvas part. So I select it. Also I am interested in some scripts. This one is new, this one is new, this one is new. Also I can copy event system, it's needed for working with the canvas. Okay, you need to also pay attention to the resolution of the screen. So if you see this part some way different way, so here you need to select the resolution, this one, or if you don't have it, you can edit manually. So you change this and this to similar settings. So here you will see it in the correct way. Let's continue to select items. Also I need the camera attached to the end effector of the robot. This camera attached to the gripper. Again, scripts, camera, canvas, event system. So these items I wanna copy to my scene. Let's click Ctrl C for copying them, Ctrl C on keyboard, and then I open my import scene and paste Ctrl V here. Here some errors. What errors is that? Because we need to blue cube of canvas. Okay, so we need to reassign blue cube variable here for the canvas script. So maybe some dependencies will be lost, so we can fix it. For example, here you can see that objects are missing. I didn't copy them from the previous part, from the test scene, so we can add them here manually. These 3 cubes. Also, let's activate them and add them to the canvas changes script. The blue cube, the green cube, cube blue, cube red. So this part won't have errors. Next, let's also locate some scripts here, so they will be in the right place to keep not so many things here. So we selected the scripts and moved them to the scripts folder. Here we also missed base origin. We know that our base is here, and we need to give our robot the understanding of our cubes. More clear about that will be a bit later. So, but now we need to move this base origin to here. So here we don't have any other missing objects. Here is our camera C. We need to attach it to the end effector. We open robot joints and scroll to the end effector part. For example, here, EE origin, we move our camera C here. So here's our camera attached to the end effector. Next, so we manage with the scripts. Here's our canvas, and here's the objects included to our canvas. Robot part corresponds to the joints. So here we will see joints of our robot. Here is this part. So here we just displaying the robot parts. Next, we worked with the cubes. Is this part we can here is written the main information, for example, size of the robot. We need to know size of the cube, sorry. And the origin of the cube is located in the middle of the cube. Also we can reset position of our cube, and we can hide particular cubes. And the last part is the point clicker. So where we click on our script. Firstly, let's briefly consider the joints script. So here we need to, as I remember, we need to modify the scripts of the robot test. This script we need to modify. Robot test. I will copy values from the other script, from this one, from this test scene. Scripts, open the robot test script. So in this part, robot test, we need to put values. We need to locate input fields, and we need to provide the values to it. So we didn't do it before. So first of all, we need to add input fields, and then we modify these parameters. So firstly, input fields, let's copy them here. It currently is highlighted, so we need to add the corresponding namespace using Unity engine UI. So That's how we can work with the input fields. We need to connect this namespace. Next, I will also copy this part. So to our input fields, I will provide the values of the joins. And as input field work with the text format, so I need to convert this float format to the string format. So you can type these things manually, for example. Okay, let's save this part and go to the Unity. Project. Go to the robot script, and now we need to attach elements of this canvas to corresponding fields. Where is the canvas main, robot, input field 1. So they all located. Here's J1, J2, J3, 4, 5, 6. Robot 1, and start to drag and drop them. Here I use the input fields, not text, because maybe later you will decide that you wanna change these values. So you make the input field, for example, interactable, and then you will be able to change joins from here to work with the robot joins. Next part. So that's what about robot, how we display things here. Simply convert angles to our text. Next part, operation with cubes. Here we work with the script canvas changes. Let's take a look at this script. Here firstly we created our cubes, red, green, blue. Next we created corresponding input fields for checking the rotation, the position of every cube, rotation of every cube. So here are corresponding input fields. So inside the update we display the position of every cube and rotation of every cube. So we got access to the parameter rotation or position and convert it to the string value as we work with the text of the input field. Next, what we do here is to work with the toggles. So we will activate the cube. By default they all activated, so we work with that toggle. We reset or we activate the cube. So if you check this toggle, cubes. So here you'll see this toggle. So here we touched our script canvas changes, and here we use function red cube toggle. So you also need to activate these functions here. But if we imported them from another project, so they were activated here by default, but you need to understand how you can add this toggle. Also here the function will be the function for raise the cube. Again, our script canvas changes, and here we use function raise cube, so it will be raised to its default position. This function raise cube, so here we provide the default location of our cube. And again, change the input field itself and also change the location of the cube in Unity scene. So that's what we do here. Display the cube position, orientation. Next we can activate the activate cube, and also we can raise it position, rotation to the default state. That's what about this part. Currently we consider it joints, not this project. We consider joints, cubes. Next, what about point clicker? This script is the script screen point to array. Is this script screen point to array. Here we're interested in base origin and these positions. So what this script does? Screen point to array. Here we have game object base origin. We display the position of our clicker. So here we detect the left mouse button click corresponds to 0, which means the left mouse button we detect. Next we create the array and we detect the hit of our array. Once we detect the hit, here is the hit point, and we make a difference between our origin point. So what we do here, where we click the mouse button, for example we clicked it somewhere, for example we clicked here on our cube. So what it will do, it will create the array for us. For example, here is a plane, and we create the array. Here is the array. For example, here is the array, and here is the heated part. So we detect this part. So we've got the location of this point. But here is the world point, and we need to provide our robot the understanding where is the cube. Robot, for example, only knows where is the base of the robot. For better understanding, let's take a look at this object. For example, here is the base, and for example, here is the cube. So by mouse click, we detected this point somewhere in the world. So how to get our robot understanding where is it? Robot only knows where it's his base. It has joints with some default length, so it knows the size of the robot, so it can also understand the gripper point based on the base. So first of all we need to understand where it's located with regard to our base. So we need to understand that we know where is our base in space, and we know where is our object in space. So that's why we make difference here between these 2 points to understand what's the difference. So this procedure will give us understanding where is our point is located based on the cube. For example, for this procedure we also need to move all of the cubes to the base position. For example, in the testing script, we can compare the, for example, if you check the green cube, this position corresponds to this one in the canvas, and it is based on in a reference to the base point. So robot will understand. So this way we exactly same points we detect with the MATLAB. So robot can calculate the trajectory to this point because they are based on the base point. So similar way we need to move our cubes to the base origin here. So now we will compare the green, blue and red cubes. They should have similar positions. So here the Y corresponds to the Z, this because of the MATLAB, and Z corresponds to the Y. In order to see in MATLAB and in Unity similar points. Let's currently test these three parts. We didn't test it yet with a new project. So here, firstly the robot joints. So I rotate the robot and I see changes in our joints. Next part, I can, not here, I increase it. I can activate, deactivate my cubes, and also I can reset the position. No, here I can't. Why? Let's check why I can't reset. Canvas changes the script reset positions. Sometimes parse function doesn't work for me. Maybe we can try another function, try parse. Let's search for the function try parse. parameters. Well, let's try this example with a parse. Firstly, maybe this way it will work. So we modified the reset red cube XYZ, reset this position. So this one works. Example, if I will try another one, it will give me an error. Before I created the scripts on my MacBook, maybe on MacBook it will work, but here on Windows it doesn't work. So I will create similar for other parameters as well. Okay, save and go back to Unity project. Let's try to move our cubes in a scene somewhere and then try to reset their position. Blue. So reset green, red, blue. So it's worked now. Also, let's attach the camera manipulation script. We have camera main here. So what we want to make is to find our camera operate script and drag and drop it here. Here is the sensitivity of this script. And if you check the script, here it will give you some explanations on it, on every line, so you can read it yourself, and also how to use it. So now, if we start it again, our script is attached to the camera, so now we can manipulate with our camera on the scene. Now let's check the point clicker part. So if I will click somewhere here, I need to see pretty similar points to the green cube and other points as well, so any other. So screen point clicker also works. In the previous project I also have these objects. Let's also copy them and paste. we need to find again scene, save this one, open test scene, and I wanna copy these three objects to my scene. Select them, Control C. Our previous scene, paste them here, and we need to locate them with regards to our base region. So these points we will provide to the MATLAB script. Also, in order to see similar points in MATLAB and in Unity, currently we can see similar points for X, for Y, for Z. For example, let's try to start it. For example, here it's for the blue cube. We can see the difference only in this sign, in this minus sign. In order to make simple changes, we can remove this minus here and add it here. So these points will be similar with the Unity and Matlab. So we add minus to our function, to our translation function. So minus y should be here all of the time. And don't forget about it. And also I will remove it from here from our default page. Again, canvas main, cubes, and display positions. Input field 1, I will delete minus from here. Minus from here. Minus from here. So that's how we made changes in our scripts. So we made different changes. Let's also check that everything is still working. So we hide these objects and we try to grab this blue cube. So we run the script. Currently it's not working, some socket error. Why? So I will restart everything again. Unity and Matlab. Not Matlab, just Unity. Okay, Unity was restarted. Let's start it one more time. Previous time it didn't start server for us. So now it was started, so Matlab should work. I didn't hide previous cubes. Okay, let's start one more time. I will hide a green cube, red cube, and we'll grab the blue one. so it works as before. Now let's move to the next part, how to send image to the Matlab. So in the third part, again, we need to open our script server, and we need to create a new function in the Matlab. I will copy it from the previous one. So here we are interested in this function. I will copy this function to our project. So let's take a look at it. Here we worked with the case camera. So here we need to create a new case for the camera. I will also probably copy it from the previous file. Do not write all of these things. Scripts server. So we need to add first a new case for the camera. I need to write these things. I need to write a function. So it will work with our image. Here we need to make sure that, so save it. So here we will get access to this script. Here we need to make sure that the object itself and script has the same name as we make reference to them. So this object, camera, should be similar to this one. And script itself attached to this object also similar to this one. So here we will work with the camera, which is attached to the end effector of our robot, and this script also displays the streaming of the camera to this part of the canvas. Next we move to the Matlab project, and here we need to write a new function for it. For example, let's first just try to test this function. So how to call this function? Where is it? Here it's also inside another function, color check. Let's also import the color check function. Color check. Also, and open this function. So here's how to get the streaming of the image. First, let's just run this. Let's just get the image first. So first we need to connect to our server. And next we need to get the image, and we wanna display it by the function imShow. So now let's try to start the Unity and get the image. So currently I hope to see this image. Let's try to run MATLAB, run section. I want to just run this section and get corresponding image. So I see this image here. We can change size of this image, for example, to a higher resolution. For example, if I will change these numbers, I will see higher resolution. Also, let's try to rotate the robot to see something different. So, for example, to see something like this, run the MATLAB, run this section. Where? Because I changed size. Let's take a look at the script. Okay. So what if I will change same here? MATLAB again. One section. So show me this image, but the resolution, different resolution. Camera. Let's try to change. Start. So why it's not changing? Okay, currently it can work just with the 240 resolution. I will check why and let you know later why I cannot change it. Maybe if I change it in the start it will work. Okay, let's try this last time. Okay, now it was run correctly. So if you wanna change this resolution, you will need to change it during the start. Yeah, because during the start we get the resolution of the image. So if you want to get the higher resolution, then you need to change it during the start. 360. Let's run it. Change our robot to some different orientation. So let's just play this image and it will be the 360 resolution. Again, run this section. So we see correct image and we can also see the resolution 360 by 360. Next, let's take a look to the color check function. What does it do? Color check. Here we firstly I make it in a way of function, because in order to do not write this part of the script every time. So here we just call this function and we detect the particular color. If this combination of pixels, here we get access to the R channel, G channel, B channel, and then we compare them. If it's this combination, it corresponds to the red color. For this combination, it will correspond to the green color. If not, it will be the blue color. So we use this idea for the detecting colors. Next I will just copy this script and explain it to you, so in order to do not write it again. So here's our main script. So what do we do here? Not all, maybe, because it may be different a bit. Okay, looks the same, so I will just copy it. So what do we do here? The cubes are located one above the other, so the position are different, is just the Z position of it. So currently this one corresponds to the green cube. It has these coordinates. For example, if you take a look to the green cube, it has similar coordinates. 9, 3. You can change. I will run it. Will it change or not? Yeah, okay. So let's compare them. Same. Then for the red one will be this one. For Z coordinate will be this one. So we, during every step, we just change the Z position. Next, here should be minus, as we mentioned before. And during the first loop, we just moving our robot to the cube. Once we approach to the cube, we call the function and detect the color. So this color check function will be called. Next, we specify the placing positions. For example, here the red sorting, here the green sorting, here the blue sorting. So how did I get these locations? So let's make double window. So I've got them with the aid of the, for example, we can get them based on our point clicker. So if we scroll it, then for example, if we check the red sorting position, we click here in the middle, it will display us similar things. X, Y, and Z will be something pretty similar to 0, so it's almost 0 because they are on the same plane with the base region. So here we operate only in a 2D space. This is the origin of our base. So in order to get it more clear, let's take a look to our scene. Find our robot. So he is the origin of the robot and he is the position of this object. So this is just the 2D space, not 3D. And why we added the 0.04? Because this is the middle of the cube. So if we put just 0, the cube will be inside the table. So we need to add the 0.4 for it. Or we can add something a bit bigger. Then the cube will be dropped by space. For example, here's the full size of our cube. We note from here, not 0, but this one. And here let's add something bigger, so it will be dropped from the space, for example 0.5. And let's test it. So firstly, if the color will be red, if we detect the red color, it will be put here. If the color is green, we put object here, and if color is blue, we put it here. So once we detect the color, we can grab the object. We wait till it will be grabbed. We firstly move to initial position, and from initial position we put our object to the sorted place, to where we want to put our cube, to these positions. So we next move to this position. Once we approach to it, we release our object, grab equal to 0, we send this function, and we remove our robot to initial position. So let's try to test it together. Save this scene first. Start it. So firstly let's try to test with the green cube. Run the whole program. Run. So to move to the green cube, detect the color, put cube to this position. Next, we interested in a red cube. We run it, detect color, move our robot here, and that the blue cube. Here we've got some error for the blue cube, it didn't calculate us the trajectory of the Z object. Let's try to put some other value here. Let's just test with the Z cube again. Started with the blue cube. And Matlab. I put some bigger value here, so it didn't calculate as the trajectory. For example, let's put some smaller value to it. Let's try 2 and start the whole script again. So it should drop from somewhere up. That's what I wanna get. So from here we put some bigger value, not the smaller distance, but something smaller to it. So we dropped different cubes from different space. For example, the red cube was placed very gently. The green cube we placed with some position, and the blue cube we dropped from somewhere up from the space. So that's what about this part. So we can also write a loop for this function. So in loop we can change these parameters for sorting cubes. Here we sort them manually, so maybe we can just leave it manually here. Save. Let's try to test it one more time, just one by one, section by section. Again, start the program. Let me first change name of the script. I will rename it to the Part 3. And next test it step by step. First of all, during the first step we attach our gripper to the cube. So we just run this section. We attach gripper to the cube. And next we detect the color of the cube. So we use the function color check, and it will call the read image from the gripper. So this green image we will read. So run this section, we will get this image, and we detect the color of it. Next we grab the object. So we start this section. It will take the object, and it will also send the robot to the initial position. So we run this section. The gripper is working, the robot moves to initial position, and next we place the cube to the sorted place. So here we detect the color, so we place our cube to this position, and here it will add some space between cube and floor. Run this section, and here it will drop it, and back to initial position. Again, all together with the second cube, and the second cube it will place very gently here. So run all together, detected color, put very gently here, and the last cube we will drop from the bigger distance from Z with some height. Grab it, and next drop it. So that's all for this part. Thanks for your attention.